In the last unit, if I gave you some zeros, like this, and I said, write a polynomial with degree 3 that has those zeros. What we did was take them and first put them in factored form, meaning what factor gives you x equals 5 for a 0? X minus 5. And then x equal negative 2 comes from the factor x plus 2. X equals 4 comes from this factor. And then what would we do to those to write a polynomial? We would multiply them all out. Like we would do FOIL on the first two. And then whatever we got there, we would then multiply by the x minus 4. We'd get a whole bunch of crazy stuff. Be sure it was in standard form, right? Like the degrees were decreasing, and then that would be our answer. And that's what we're doing today, except instead of something like 4, we might have 4 minus 2i. And so we're going to talk about how this works with complex numbers. So when I'm saying complex, I'm talking about something in that form, a plus bi, okay, which is from several units ago. So what I want to begin with is, you see all these words here? A lot of times when we have words on your notes, I go like this, blah, blah, blah. Let me just show you, right? I don't want you to blah, blah, blah. I want you to read this. So actually take a moment and read those things. These are the 3 main ideas we'll be using on repeat today for the lesson. So read those to yourself real fast. Hayden, read the first one for us, please, out loud. The first bullet, please. No. Yes, out loud. Perfect, thank you. Okay, so what that is just general, n standing for any number. This is something we talked about before. It means basically this. If you have some polynomial like this is just an example. Don't get attached to it. It doesn't mean a whole lot. How many zeros would this polynomial have? 4. That's your degree. The degree is the highest exponent that the expression has. And whatever that number is, that's how many zeros it's going to have. So we'll be talking about that today. So that means this would have 4 zeros. Nathan, please read the second bullet for us. All right, thank you. That was important. Okay, so zeros can repeat. For example, it might have a double root. So like in the last unit, sometimes we would factor, and I would ask you to tell me what the zeros were. But when we factor, we might get something like this. Which one of those factors would give me a double root? The x minus 7. It really only has one answer to it. What's the 0 that goes with these factors? 7. But the multiplicity is 2. It occurs twice. This is a double root. All right, so that's something to keep in mind when we do our problems today. Cassie, please read the last bullet for us.
Conjugate pairs theorem says if a plus b I is 0, then so is a plus b.
Thank you. So you might not remember this, but when we talked about complex conjugates a while back, we said that one of the reasons we even have that as a thing is this. If you were to multiply them together, you would FOIL them, and what happens is the middles would drop out, and you'd be left with whatever this value is, which is a real number. And so the reason why, if you have one, you can assume you have the other is because when you multiply them out, the original polynomial has to have real coefficients. The i's have to drop out. So what this is basically telling you is, if I'm going to give you a 0, like I'll say, oh, hey, here's a 0. X equals 4 minus 2i. You automatically know, without me even having to tell you, that the conjugate also has to be a 0. What is the conjugate of 4 minus 2i? 4 plus 2i. Okay. These will not be found alone in the wild. Okay. They have to be together. When you have real number coefficients, which we do. So keep that in mind. We're going to tie all this together here in just a little bit. So in this example right here, we're not yet doing all the foiling and the multiplying. We're just being sure we know how to figure out what all the zeros are. So it says find the remaining zeros of a polynomial that has degree 5 and those given zeros. How many zeros did this problem give us? How many zeros do we have? No, we do not have 4. Look where your commas are. How many are there? There's 3, right? So let's be careful that we know what's going on. So we have a 2. We have 3 minus 2i. And we have I, all right? How many of those are complex numbers? 2 of them. 3 minus 2i is one complex number. I is one complex number. How many of those zeros have to have a conjugate that's paired up with them? 2, the ones with the i's. Okay, it's only the ones with the i's. So that means that if 3 minus 2i is a 0, conjugate also is. What's its conjugate? 3 plus 2i. This one has to be a 0 as well. And if I is a 0, its conjugate also is 1. What's the conjugate of just I? Negative I. Now how many zeros do I have? 5. Okay? 1, 2, 3, and then 4, 5. 3 plus 2i is a 0. Negative I is a 0. Okay? So again, be careful that you keep this straight. The only time you are using the conjugate is if it has an I there. Notice, too, I didn't do negative 2 to pair with it. You don't have to do that. But how would this problem change if what if the degree is 6? Where would that 6th 0 come from, do you think? So far we have 5. We already have the conjugate pairs. Be a double root. Which one is a double root? The 2. Exactly. All right. So once you had 2 as a double root, then you would have 6 zeros altogether. So zeros can repeat, which is what was right over here on that second bullet. Zeros can repeat like a double root. Okay. And we're going to come back to this later in a problem, so that you'll get used to the idea. Does anybody need this up anymore? All right, now this slide is an aside for a second. It's a shortcut, because you're about to do a whole bunch of foiling and crazy multiplying. So if I can save you some work, that would be great, and that's what this shortcut does. This shortcut is for multiplying complex conjugates. It's only for that. Okay? It's not something you would use wherever you want. You have to be careful about the context. So if you have 2 complex conjugates being multiplied like we do here, you can skip all the foiling process and simply just square the A term, square the B term, and add them up. The only thing is you have to be able to figure out which is the A and which is the B. So in this specific example right here, I'm going to rewrite this in general form here. We do have an A plus BI and an A minus BI. What's in the A spot in this example? X. So A is X. And to figure out what B is, you have to be very clear about something. B is only whatever the coefficient is on the I. It doesn't include the plus, it doesn't include the minus. It also does not include the I piece. It's strictly whatever's in front of the I. So in this specific example, what do you think B is? You're not making it a plus or a minus, you're not including I, it's just 5, just 5, I know 5. Because this formula right here already takes into account the plus and minus portions. So you don't have to change any signs, you just have to pick off the B part. And so then if you're skipping straight to a squared plus b squared, you have this. X squared plus 5 squared, which is x squared plus 25. Real quickly, I'm going to show you why that works. This part you don't have to write down if you don't want to. If you want to just watch, that's okay. But let me show you why this shortcut works. If you were to FOIL x minus 5, x plus 5i, okay, you do your first terms, x squared. The outside is the x and the plus 5i. Multiplying those things just means smushing them all together. So it would be this. Plus x times 5i. Okay. When you do your inside terms, it's here. Negative 5i and x, you just smush them together. And then L is your last terms, right? The L in the FOIL. That's negative 25i squared. What do you remember about I squared? It's negative 1. Okay. So what happens to those two middle terms? They cancel out. They're the exact same thing, only they have opposite signs. And you just told me that you remembered that I squared is negative 1. And what's negative 25 times negative 1? Okay? So that's what this shortcut rule is doing for you. It's bypassing that middle step where that step where the middle terms cancel out. That will happen every single time as long as you're multiplying conjugates. And then the reason why it'll be plus every time is because this will be a negative times a negative. Right? So that's why you can do this shortcut. Now let's say you're like, shortcuts, I'm not going to remember that. I don't want to do it. It's just going to give me stress about not remembering how to do it. You can always just FOIL and you'll get the exact same thing. So it's whichever you like to do, okay? I'm going to do the shortcut up here because to go faster, and it's just good for you to see it. Does anybody need this up anymore? Okay, so let's put all this gobbledygook together. We have this problem. Form a polynomial f of x with real coefficients having the given degree and the given zeros. How many zeros did the problem give us? 2. But how many do we need? 3, because it says the degree was 3. Which one of those things generates a second zero for us? The 3i does. Well, even before that step, okay, even before the factored step, if 3i is a 0, what else is a 0? Negative 3i, okay? So that's a complex conjugate pair. Complex, or just conjugate pair, or whatever you want to write. So there's my 3 zeros. 1, 2, 3. So here's how we use them to write standard, or to get our polynomial. The first thing we want is our factored form. What factor gives me x equals negative 5 as a 0? Excuse me. What factor do I get from this? X plus 5. Okay. And then what factor do I get from x equals 3i? X minus 3i. And what factor do I get from negative 3i? X plus 3i. That's right. You're just taking the opposite sign. And then here's where the math for the day comes in. We need to multiply all that out, all right? You could start with these two, FOIL them, get your answer, and multiply it by the third one, but I don't recommend you do that because your math will be unnecessarily complicated. I'm going to start with the second two. These, why do you think I'm going to do that? Because the middles are going to cancel out, and we can use that shortcut that we just talked about, right? So what I'm going to do is just bring down that first factor and just let it hang out for a bit. So I'm going to do the a squared plus b squared shortcut. So just bring down the x plus 5. It's going to hang out here, dancing by itself in the corner. So if I'm going to do a squared plus b squared here, what does a equal? What's in the a spot? X. What's in the b spot? 3. So a squared plus, blah, 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 blah. A squared plus, blah, blah, never mind. Looks like this. Okay. And what is 3 squared? 9, absolutely. So really I have this. And I want you to FOIL that and write your answer in standard form. Take a moment and do that. Raise your hand if you got this. Questions about this? Okay. That one's not so bad, right? Let's look at this one, which really isn't also that bad, not that bad, but it's not terrible. Take a second and just figure out what the zeros all are. If you don't feel comfortable writing in factored form, you don't have to. Just figure out the zeros. Almost done. On the back. Almost. It's almost right. It has a lot of good. It's mostly right. Which one of these has to have a conjugate paired with it? The one with the I. So if negative 3i is a 0, what's its conjugate pair? Plus 3i. So those are conjugate pairs. True or false? Well, first, even before I get to that, how many zeros do I have right now? 3, and I know I need how many more? 1 more, right? Because I need 4. So I have to like Sherlock Holmes this a little bit and think, okay, where else can I find more information? And this is where I can find more information. True or false, it has a conjugate. False. How do I know this one isn't the complex conjugate stuff? There's no I. Exactly, there's no I. So if I need to get another 0 from there somehow, my only option left is it has to be a what? A double root, which means it's just exactly the same. It's just repeated. So now you have your 4 zeros, right? So that's the first step of all the problems, is just to be sure you have enough zeros, and if you checked for complex pairs and repeating roots. So then from there you do your factored form. How many x plus 2's do you need? 2, right? So it's not enough to just notice it has 2 zeros or that it repeats. You also have to understand that means you write the factor twice. And then you have your factors from the 3 i's. So then you will use two different methods here. FOIL on this one, and a squared plus b squared if you like that shortcut. Otherwise, you're welcome to just FOIL. So take a few minutes and do your math. I'm going to do my math up here. Don't look at my math. Do your own math. Don't look at mine until you're ready to check yours. I'm going to do it real small so you can't see it. No, just kidding. I want you to look at your foiling that you did for the x plus 2 times x plus 2. Please be sure you didn't just do x squared plus 4. The reason why that's been happening all day is because of the a squared plus b squared shortcut. But that x plus 2 squared is just regular FOIL, which means you have to do the first, outside, inside, last. That gives you 4 different things, and then the 2 in the middle combine. So you need x squared plus 4x plus 4 times x squared plus 9. Who's to this step correctly? Okay, so then after that multiplying, you have options. You can do box method if you like box method. I'd like to just think of it as repeated distributive property. So I think of it as distributing the first term into that parentheses, and then the second term, and then the last term. And then I just combine like terms. So go ahead and finish yours. Again, don't look at mine until you're done with yours. Because you can't unsee what you've seen, and then you feel like you understand when maybe you didn't really. Make sure your answer is in standard form. Oh my gosh, how long is this answer? If you're still working, keep working. If you're finished, raise your hand if you've got this. That part of your notes that says do number 25 from the homework, I originally was going to give you your homework, and then we're going to do 25 together, but it's obnoxious and unnecessary roughness, and it's the Monday after a holiday, so we're not going to do it.